Okay, so today we'll start with trig review, and we'll start the very first thing we'll deal with the right angle triangles. So a right angle triangle is a triangle that one of the angles is 90 degrees. So if you see a triangle like this with this little sign here, that means that this is a right angle triangle. For simplicity, we will label the triangle as ABC. When we are labeling the sides of the triangle, those will be with a will represent, first of all, the length of the line segment, and will be with a lowercase letters. And the letters will be the opposite of the angle. So if we have the angle A, or vertices A, then the opposite of that angle is the length of the line segment BC. And then we assign it with a lowercase a. And if we are looking at vertices B, the opposite side of it is AC, so we will label it with a lowercase b. And the last one is angle C, which, or vertices C, which is the vertex that has the right angle triangle, and we will label it with a lowercase c. The famous formula that you all already know is known as the Pythagorean. So it is a squared plus b squared is equal to c squared, which is telling you that the length of the line segment A, lowercase a to the power of 2, added to the length of the line segment B, lowercase b to the power of 2, will give you the length of line segment C to the power of 2. In other words, this can be CB plus AC squared is equal to AB squared. So this is known as the Pythagorean theorem, which you have seen. However, if we have a right angle triangle, what we will focus today on is, let's suppose that we have the triangle ABC again, where angle C is a right angle triangle, and the length of the line segment BC is A, of the line segment AC is B, and the line segment AB is C. In other words, C is known as the hypotenuse of the right angle triangle. So the hypotenuse is the longest side of the right angle triangle. And then the two other sides, A and B, in our case, will be interchangeable. Sometimes they will be opposite and sometimes they will be adjacent, depending on which point of view we are looking at. So if we are looking from the vertices A, meaning that you are putting your eye here, then the opposite of what you see, the opposite of the angle A, is the line segment BC, or line segment A. And the adjacent is the line segment B, or the line segment AC. But if we have the same triangle, and now instead of angle A, we are looking at angle B, so we will see from this point of view, then B will become the opposite and A will become the adjacent. So always when we are defining the opposite or adjacent, we will say it in the relation to angle A or angle B, because the hypotenuse is always the hypotenuse no matter what. Okay, so now one thing that we have to keep in mind, or why are we doing this, is because what we do in trigonometry is we use those that are known as the trigonometric ratio, or trig ratio in other words. So the ratios that we use in trigonometry are sine, cosine, and tangent. Sine is opposite of the angle over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In order for you to simply remember this, what we do is we say that we are using so, ka, to. So, ka, and toa. Or sometimes teachers write them as so, ka, as in one row. It doesn't really matter how you write it. I prefer it this way because you see that is a ratio, but you can write it on this way. I am fine with it. What that means is that the sine of the angle, let's say A, will be opposite of angle A over hypotenuse. So let's take another triangle, a right angle triangle. Now we'll make it a bit weird looking. So if we have the triangle RPP, RPQ. And let's say that we are looking at angle Q. So when we find the sine of angle Q, this will be opposite of opposite, which is RP over hypotenuse, that is PQ. And the cosine of angle Q will be adjacent, RQ over hypotenuse, PQ. And if we are looking for tangent of angle Q, will be opposite, which is RP over adjacent, that is RQ. But if we take a look, and then for the same one, we now find what is sine of angle P, then opposite of angle P is RQ. So RQ over, this is always hypotenuse, doesn't really matter, PQ. Cosine of angle P will be adjacent, which is RP over PQ. So always when you are finding the ratios of trig ratios, what do you have to do is you have to first identify the opposite and adjacent of that angle, and then figure out what is the length of the line segment and opposite and adjacent and or hypotenuse, and then using SOHCAHTOA find the sine of the angle. So let's move now to some examples on how to find the sine ratio. So let's suppose that we have the triangle in which two of the sides of the right angle triangle are 12 and 15. For simplicity, we will label the triangle, so ABC, and let's find the sine, cosine, tangent ratio of angle B. Okay? So before we do so, we have to figure out what is the length of the line segment AB, which is the hypotenuse. No, as we said, no matter where are you looking at angle A or angle B, the hypotenuse will be hypotenuse. So on this case, we will use the Pythagorean. So a squared plus b squared is equal to c squared, which means in our case, 15 squared plus 12 squared is equal to c squared, which is the hypotenuse squared. So from here, we find, using the calculator, that c squared is equal to, so using the calculator, you will find that c squared is equal to 369. And the square root both sides will give you 19.2. And I will keep it one digit after the decimal point for now, but you can do whatever you want. So the hypotenuse now is 19.2 units. In order to find sine of angle B, we'll go opposite of angle B over hypotenuse. And the opposite of angle B is AC, so will be 12 over 19.2. And in your calculator, 12 divided by 19.2 will be 0.625. So the sine of angle B will be 0.625. On the other hand, cosine of angle B will be adjacent over hypotenuse, and the adjacent of angle B is 15, so will be 15 over 19.2. And again, in your calculator, 15 divided by 19.2 will be 0.78125. So cosine will be this one here. In the same way, we'll find tangent. So tangent of angle B will be opposite over adjacent. So opposite over adjacent. And opposite of angle B, as we said, is 12 over 15. In your calculator, 12 divided by 15 will be 0.8. So tangent of angle B will be 0.8. If we want to find what is the value of angle B, then what we will do, either using sine or cosine, I will use cosine for now, we will go with the inverse. We'll find the inverse. So angle B will be inverse cosine of the ratio, 15 over 19.2. So in your calculator, you can reach it with second function cosine, and then you will see a cosine to the power of -1. And then you enter the value of cosine, and you will have 38.6 degrees. Make sure that the node of your calculator is on degrees, and then you will be able to see that angle B is 38.6 degrees. If you want to see how to use the calculator on this, then will be second function cosine 15 divided by 19.2. Enter. And the mode of my calculator is not on degrees, which means that I have to convert it into degrees. And we'll say 38.6. Okay, so let's see another example of finding the angle when the right angle triangle is given. So let's suppose that we have this as the right angle triangle, RPQ, and we are looking for this angle theta here, knowing that we have the sides PQ as 8 and the sides of RP as, let's say, 12. So now the sides that we know are opposite in the relation to the angle and hypotenuse. So then you will ask yourself, what is the trig ratio that relates opposite and hypotenuse? And it is sine. So sine of angle theta or sine of angle R is equal to opposite over hypotenuse. And opposite in our case is 8 over hypotenuse is 12. So in your calculator, what we will do, what we will do in order to find angle theta or angle R, we will go inverse sine 8 over 12, and then this is what we'll do, sine inverse sine 8 divided by 12, you may close brackets or not, doesn't really matter, will be 46.7 degrees. Or let's bring another example where we have a right angle triangle that look like this. And now again RPQ. And now what we will do is we'll have, or we do have as a given, this side here as 13 and that side here as 14. It doesn't matter what units are they, and what we are doing is we are looking for angle P. So in the relation to angle P, 14 is the opposite and the 13 is the adjacent. Now, the question that you have to ask yourself is, what is that trig ratio that relates the opposite and adjacent that are given here in our triangle? And that trig ratio is tangent. So tangent of angle P will be opposite, that is 14, over adjacent, that is 13. And from here, angle P will be inverse tangent of 14 over 13. Then in your calculator, what you do is you go inverse tangent 14 divided by 13, and this will be 47.1 degrees. 47.1 degrees. Now let's move to another part when we know the angle and we are looking for one of the sides. So let's say the first case is, let's suppose that we have a right angle triangle as ABC, and one side, well, let's say the A side AB is 18 and the side AC is, no, we are looking for the side AC, knowing that angle B is 30 degrees. So now, in the relation to the given angle 30, the side that we are looking for is opposite, correct? And the side 18 given, since it is the longest one, is the hypotenuse. Okay, so now again, the question will be, what is the trig ratio that relates the sides and the angle that we are looking for? So in this case, so will be sine. Sine of 30 degrees is equal to whatever we are looking for over hypotenuse, or x over 18. So now this is a simple math. We have this as the equation. Sine 30 is equal to x over 18. In order to solve for x, we will multiply both sides by 18 because we want to cancel out the denominator, and then x will be 18 times sine 30 degrees. And in your calculator, 18 times sine 30 will be equals to 9. From here, you can solve even the further one. So this is 9 now. You can either use cosine to figure out what CB is, or AB plus B, A squared plus B squared is equal to C squared. Okay. So let's see another example in which we are looking for the side. Let's suppose that we have a right angle triangle that looks like this. Okay, so we have this angle here as 15 degrees. And what do we know is that the hypotenuse is 23, and the side that we are looking for is this one here in the horizontal direction. So now, in the relation to the given angle, x is adjacent, and 23 is hypotenuse. We always will ask the question, what is the trig ratio that relates adjacent that we are looking for and the hypotenuse that is given? And the answer will be cosine. So cosine of angle 15 is equal to x over hypotenuse, that is 23. And again, by solving it, we will have to multiply both sides by 23. So x will be 23 times cosine 15 degrees. Or when you enter it into your calculator, 23 times cosine 15 is equal to 22.2. 22.2. Let's see another example where we are finding the hypotenuse now. So we have a right angle triangle that looks like this. This is the right angle, and this is 13, and this is 8. And let's not give this number here yet. So 13, and this angle here is equal to 25 degrees. And we are looking for the hypotenuse. So now, in the relation to the given angle, the 13 is the opposite, and x is hypotenuse. So what is the trig ratio that relates the opposite and hypotenuse? And it is sine. Sine 25 degrees will be equal to 13 over x. Now we are solving for x. So multiplying by x both sides. And then we'll have x times sine 25 is equal to 13. And then dividing both sides by sine 25. So x will be 13 over sine 25 degrees. In your calculator, 13 divided by sine 25 will be 13.8. I hope that this makes sense because we will move into sine cosine law. So sine cosine law deals with triangles that are not right angle triangles. If SOHCAHTOA deals with right angle triangles, sine and cosine law deals with non-right angle triangle. So with a triangle that none of the angles is 90 degrees. A triangle that looked like this, ABC. Then what we will see this is side A, this is side B, and this is side C of the triangle. And then the sine law is sine of angle A over length A is equal to sine of angle B over length B is equal to sine of angle C over length C. Sometimes you see it like this, or you may see it as A over sine A is equal to B over sine B is equal to C over sine C. Both of them are right, and we are using them in cases when we can apply it. So we can use them 2:2 ratios like this, or like this, those two ratios, or like what is left now, those two. Depend on what is given and what we are looking for, then we can solve the problem that we are looking for. And the cosine law is, again, if we have a non-right angle triangle, let's suppose A, B, C, where BC is length A, AC is length B, and AB is length C, the cosine law is written like this: A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. From here, you can find the angle as well by using cosine A, or you can apply sine law to figure out what the problem is asking you for. Let's take a look at some questions. That are dealing with sine and cosine law. So let's suppose that we have a triangle that looks like this: A, B, C, and angle A is 60 degrees while B is equal to 20 and C is equal to 30. And what we are doing is we are looking for A. So in this case, when we see that we have this kind of triangle, by knowing the sine and cosine law, we can apply the cosine law straight away. So a squared is equal to b squared plus c squared minus 2bc times cosine a, or a squared is equal to 20 squared plus 30 squared minus 2 times 20 times 30 times cosine 60 degrees. From here, a squared will be equal to 700 if you go with a calculator, and then squaring root both sides, we'll find that a is 26.5. This is applying cosine law. Now let's suppose that we have a similar question, that we have a triangle that looks like this, PQR, where the angle P is 62 degrees, and what we have is this is equal to 90 kilometers, and this length here is 111 kilometers, not kilograms, kilometers. And we are looking for the distance QR. So the distance QR is P, the distance 90, PQ is R, and the distance PR is Q. Now, the way that we will apply this will be P squared is equal to R squared plus Q squared minus 2 times R times Q times cosine 62 degrees. Or if we apply or evaluate now, we'll have 90 squared plus 111 squared minus 2 times 90 times 111 times cosine 62 degrees. And from here, P will be equals to 105 kilometers. Again, this is applying the cosine law. Let's take a look now to a sine law application.